Hello everyone, welcome to Reactify Labs. Today we are going to talk about gossip protocol. Gossip protocol. So what is gossip protocol? It's a communication method in which the nodes share information amongst each other. Okay? So that's it. The nodes basically do a gossip. The nodes perform a gossip. So that's it. And why do they gossip? They do gossip to share information amongst each other. So that's the gist of it. Let's go into the formal and technical definitions and other things related to this. So it's a decentralized communication method. It's a decentralized communication method in which nodes share information with a few randomly selected peers. In which nodes share information with a few randomly selected peers. With a few randomly selected peers. That's it. It's widely used in distributed systems for disseminating data and maintaining consistency across the network. It is widely used in distributed systems for disseminating data and maintaining consistency across the network. And maintaining consistency across the network. Okay. So this is the definition. Let's talk about the key components of gossip protocol. So what are the components? First one is peer-to-peer communication. Peer-to-peer communication. The nodes communicate directly with a subset of randomly chosen peers, forming a dynamic network. So the peers communicate amongst each other. So nodes communicate amongst each other. So it's a peer-to-peer communication. Next is message propagation. Information is spread through the network by nodes sharing data with their selected peers. Next is eventual consistency. Gossip protocol contributes to eventual consistency by ensuring that over time all nodes converge to a similar state. If you don't know about eventual consistency, I would suggest go watch the previous videos in this series, and there I have talked about everything in detail and you will get a good clarification about it. Okay, great. Now let's talk about the gossip algorithm. So gossip algorithm has different parts. First part is random peer selection. Random peer selection. So during each gossip round, nodes intelligently select a subset of random peers to exchange information. The randomness helps in avoiding biases and ensures a diverse spread of information across the network. Okay. So let's say there are multiple nodes. So each node select its peers. Let's say this node decides to select these three. This node decides to select these three. This node selects these three. It's possible, right? And it exchanges its information amongst itself. Okay. Among the subset the node has chosen. That's it. Randomly selected peers and exchange the information. Second step is message propagation. selected peers actively share information about their local state, enabling a continuous flow of data throughout the network. This mechanism ensures that each node is aware of the changes and updates happening in the system. So what it does is, so the nodes, which the subset of nodes which are selected, so those nodes share their information amongst each other. Okay, so that one information is available with different nodes as well, so that other nodes also know what's happening in the system. And next is anti-entropy mechanism. Anti-entropy mechanism. So gossip protocol incorporates anti-entropy mechanisms to address discrepancies that may arise between nodes. Anti-entropy ensures that nodes actively reconcile differences, working towards a consistent and synchronized state. So what is anti-entropy? So let's say for this node the peers are these two, and for this node the peers are these two, and not this actually, let's say this two. And let's say this node gives some information to this and this node gives some information to this. So there may be conflict. It is possible that they both are not providing the same updated value of a particular data to this node. So there will be conflicts, right? So anti-entropy mechanism is used to resolve those conflicts. So that's it. Now you might be wondering, what is anti-entropy mechanism, right? So let's talk about that in detail. Anti-entropy mechanism. So anti-entropy is a mechanism employed in distributed systems to reconcile inconsistencies. Okay, it's a mechanism employed in distributed systems, including the gossip protocol, to reconcile inconsistencies and ensure consistency among nodes. Okay, it is designed to address the gradual divergence of states that may occur over time due to factors like network partitions, communication delays, or node failures, right? So it's possible, right? So let's take this example. This node writes some value, this node writes some value. It is possible that when this node wrote something, it was failed to propagate. Okay, and there was a network partition or a communication delay, and by that time this reached, this node updated that value. Let's say the value of A was written to C and this node wrote A to D. So later this node will find that, okay, both these reached at the same time, A to C and A to D. So it has to reconcile the differences. It has to know which one is the latest one, right? Because this failed to reach, so actually it should write A as D, right? So this is what is done in anti-entropy mechanism, right? So it's designed to address the gradual divergence, because divergence happens gradually because of the communication delay or network partition or some node failed, but whatever. It is also possible that, let's say, when this decided to write A to C, this node was down, so it could not reach that message. So the message could not reach this node, so it could not read that. And when A to D was written, it was active, and then both of these reached at the same time. So there may be different reasons why a particular update cannot reach a particular node, and inconsistencies may arise. So anti-entropy mechanism handles those. So how does it work? Let's talk about that. How it works in gossip protocol. How anti-entropy mechanism works in gossip protocol. First step is the detection of inconsistencies, because what we are doing is detecting inconsistencies, reconciling inconsistencies and ensuring consistency. So for that, first we have to detect the inconsistencies. Detection of inconsistencies. So nodes periodically exchange information about their local states during gossip protocol. Discrepancies may arise due to network latencies, concurrent updates, or failures, leading to differing view of the system. So as soon as we see that there are different values written by different nodes of particular data, we know that there is an inconsistency. So the detection works there. Next step is comparison of state digests. Comparison of state digests. So each node maintains a digest or the summary. Digest is summary of its local state, often represented by a hash or a checksum. During gossip rounds, nodes share these state digests with their peers. Okay. So different nodes have different states or summary or hashes, and each node shares something with the remaining nodes. Okay. Next is selective data exchange. Selective data exchange. Rather than transmitting the entire data set, what nodes do is they selectively exchange data for the portions where inconsistencies are detected. This selective approach minimizes the amount of data transmitted, thus improving efficiency. So let's say this node shares the data with this node. Okay, so it has hash h. For this it became h1. Okay, it means something changed here, right? So only the data that changed, only that will be transmitted, and not entire data needs to be transmitted, because obviously this node's information has to be replicated here, this node has to be replicated here. So depending on which one is the latest, that will be replicated at the other node. Okay, so that's when we do selective data exchange and not the entire data exchange. Okay, because obviously there is no need to copy the entire data which is already available with the other node. It's not going to do any benefit. It will only put a burden on the server. Okay, great. Next step is local reconciliation. Upon receiving data from peers, nodes locally reconcile the differences by merging the received data with their current state. The reconciliation process aims to converge the local state with the most up-to-date and consistent version. Okay, so the nodes are there, right? When they receive the data from the peers and they see the conflicts, they reconcile it, right? In this, they reconcile locally. Next is iterative process. So anti-entropy is an iterative process. So whatever we did in 1, 2, 3, 4, it gets repeated during each gossip round. Over time, this mechanism helps maintain a coherent and synchronized state across the distributed system. I hope this explains how anti-entropy mechanism works in gossip protocol. Now let's see what are the benefits or the advantages of anti-entropy in gossip protocol. Advantages of anti-entropy. In gossip protocol. So first one is consistency maintenance. Consistency maintenance. Anti-entropy ensures that nodes converge towards a consistent state by addressing discrepancies in local views. Second is reduction of data transfer. Because of the selective data transfer, we don't need to transfer the entire data. So therefore there is a reduction. Okay, reduction of data transfer. By selectively exchanging only inconsistent data, anti-entropy minimizes the amount of data transmitted, thus reducing network overhead. Next is fault tolerance. The mechanism contributes to fault tolerance by allowing nodes to recover from inconsistencies introduced by network anomalies or failures. Let's talk about some of the use cases of gossip protocol. Use cases. First one is distributed databases. In distributed databases, metadata sharing. Gossip protocol is instrumental in distributed databases for the efficient sharing of metadata among nodes. Metadata includes information about node states, configurations, and other crucial aspects of the database cluster. Next is real-time awareness. It ensures that every node within the distributed database cluster remains cognizant of the latest updates and changes happening across the network. Real-time awareness is crucial for maintaining consistency and synchronization in a dynamic distributed environment. Next is peer-to-peer networks. Peer-to-peer networks. Here, decentralized information dissemination. Decentralized information dissemination. Gossip protocol is applied in peer-to-peer networks, offering a decentralized mechanism for information dissemination. Unlike traditional centralized approaches, nodes in peer-to-peer system utilize gossiping to share information autonomously without relying on a central coordinating entity. And since there is no central coordinating entity, it means that there is no single point of failure. So there is no bottleneck. Next is redundancy and reliability. The decentralized nature of gossip protocol enhances redundancy and reliability in peer-to-peer networks. Information spreads organically across nodes, contributing to a robust and fault-tolerant communication model. Let's talk about the advantages of gossip protocol. Earlier we talked about advantages of anti-entropy in gossip protocol. Why we use anti-entropy in gossip protocol. Now we will talk about the advantages of using gossip protocol. First is scalability. Gossip protocol exhibits remarkable scalability, making it well suited for large-scale distributed systems. As the size of the network grows, the protocol remains efficient, ensuring that the communication load is distributed across the nodes. So, assume this. Let's say there is a centralized node. If it was the other way, let's say if there was a centralized node and there were 3 nodes, then okay, the load is good. Now if the number of nodes increased, so the load on the centralized node would increase. But now what happens is, we don't have a centralized node. Every node communicates among each other. So basically it's a peer-to-peer network. So let's say each node has a subset like 3 nodes. So every time each node will have a subset of 3 nodes only and randomly selected. So there is no skewed distribution of load even in case of increased number of nodes. So it's scalable. Second is fault tolerance. The decentralized nature of gossip protocol contributes to enhanced fault tolerance within distributed systems. Nodes gracefully handle failures, and the dynamic peer-to-peer communication ensures that the system remains resilient even in the presence of node outages. So now that it's a very good algorithm, there must be some challenges associated with it, right? So let's talk about them. Challenges. First one is inconsistency concerns. So guys, let's face it. If there is no centralized entity, or if there is more than one master node or a coordinating node or a centralized entity, then there can be inconsistencies. Only if the data is or the source of truth is at one place, there will be no inconsistency, right? But if the source of truth is every node, then there will be consistencies and we have to handle it. That's the trade-off that we have to do. So inconsistency concerns dynamic environments, right? Gossip protocols operate in dynamic and decentralized environments where nodes can experience frequent updates. Maintaining consistency across nodes becomes challenging, especially when updates occur rapidly or in a distributed fashion. Concurrent updates or conflicting changes across nodes may lead to inconsistency. Implementing effective conflict resolution mechanism is essential to ensure coherent systems. Okay, we need a good conflict resolution mechanism in these cases. Next is overhead. Since different nodes communicate amongst each other, there will be communication overhead. So gossiping involves continuous exchange of information between nodes to disseminate updates. The communication overhead incurred by the gossip protocols need to be managed efficiently to prevent network congestion and performance degradation. The computational and network resources required for gossiping can impact the overall system performance. So we need an efficient resource utilization to prevent excessive consumption of resources. Okay. Let's end this by seeing what are the real world examples where gossip protocol is used. Real world examples. One is Apache Cassandra. Gossip protocol is integral to the distributed database Apache Cassandra. It is utilized for managing cluster metadata, ensuring that all nodes within the Cassandra cluster are aware of the latest configuration changes and node status. Next is Erlang distribution. Gossip protocol is employed in the Erlang programming language for distributing process and node information across distributed Erlang nodes. In Erlang's distribution mechanism, gossip protocol facilitates the exchange of information about the distributed processes and the overall status of the node. So this concludes the discussion on gossip protocol. I hope this gives you a clear idea on what is gossip protocol, what is anti-entropy mechanism, how gossip protocol works, how anti-entropy mechanism works, where gossip protocol is used and other things. So that's all there is in this video. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.